Okay guys, welcome back. So in the last video we were talking about the work done by a force and when the direction of force is parallel or in the direction of the displacement. So we know that W equals Fd if the force is F and the displacement is D, the work done equals W equals Fd. So in this video I will be talking about some special conditions under which we are calculating the work done by the force F when it is displacing an object by some value. Alright, so the first special condition is when an object is lifted to some height h and again kept and again lowered to the same height h. That means a simple condition. Now if I have some object here on some table or on the floor, I'm pushing this, I'm taking this object to height h, then I have the potential energy of mgh, say I am taking the object, so the velocity change or there's no change in velocity. The initial velocity of the object is 0 and the final velocity of the object is 0 as well as 0. So the initial velocity is 0, final velocity is 0, so the velocity doesn't change, so the kinetic energy doesn't change. So also the momentum doesn't change. So only the potential energy does change, because the total work done by the system is equal to the total potential energy. If we are increasing like this, if I keep some horizontal surface like this, if I keep an object in this position, if it has mass m, so it has weight mg. If I take this object h distance up from this position, so that the position of the object will be somewhat like this. There is mg. Okay. So the potential energy of this object P is equal to mgh, is also equal to work done. You can calculate this by W equals Md as well, because the force on this object is the only force, that is mg. You are doing work against the force, so the force acting on this object is equal to the weight of this object if there is no acceleration on the object. So the force we have to give the same force as the weight of the object in order to rise it to height h. So the force on the object will be equal to its weight times the displacement is h. So the work done of the potential energy is equal to mgh. Now what happens if an object is raised to height h and lowered to the same height? Lowered to the same height. So potential energy is actually the scalar. Work done is a scalar, but we are taking h as a displacement. So h is not a distance, h is a displacement. So if we for example, if you are saying if you are increasing the actually pulling an object upwards, you have to do work against the gravity, so that the force is mgh. You are doing work against the gravity, so that gravity is against you. And if you are lowering the object, you help the gravity. That you are increasing the gravity, you are doing work with the gravity, because the gravity and the force are in the same direction. Now if you are taking this object higher up, you are doing work against the gravity, means the force you are putting is against its weight. So if it is acting upwards, mg is acting downwards, so the force acting is against its weight. So you are doing work against the gravity. But if you are lowering this object, the force and the value of mg or the weight is on the same direction, so you are doing work with the gravity. So if you are doing work with the gravity, it should have a negative effect on this object and a positive effect on you. So if you are considering the system, you have to take not the distance, you have to take the displacement of this object. So otherwise the work done will be the same as experienced by the person who is lifting this. So you take the displacement, so the work done from here to here, and take this position as A, this position as B, and this position is again A. So work done during A to B is W equals mg, and take h positive in this direction. H positive in this direction. W equals mg times h is positive, so plus mg, so W equals mg h, And if you are considering from B to A, W equals weight of the object, that's the force we are applying, times the height. Now, height is actually now displacement, as I mentioned above. So if you are taking the height as positive edge above the surface, the height that are measured downwards is minus h. So you are not actually measuring the height from downward from here, from the initial position. You are taking the height measured in the upward direction as positive, and even if it is above this earth or table or something like that, even if it is above the earth, we are taking the direction of the displacement as negative. So this should be minus h. So W equals minus mgh. So the total force done, the total work done on the system is the summation of the individual works that were done during these two instances. So from A to B, I will take the work done is WA1. So from B to A, W2. So W1 is the absolute value of W1 is equal to the absolute value of W2. Only change is the magnitude is the same. W1 is equal to W2 from the magnitude, but the only thing is W1 changes from magnitude the W2, in that the W2 changes its direction. Now, you may argue that the work is a scalar, but as you are taking a system, if you are taking a person carrying this object upwards and downwards, you have to take the displacement. So the displacement, if you are taking the displacement, you can experience the minus work done. So the total work done on the system, that's what I am actually interested about here. The total work Wt is equal to W1 plus W2. So Wt is equal to W1 plus W2. Now you have the values of W1 and W2. You just have to substitute and solve it. So W1 is equal to mgh. W2 is equal to plus times minus mgh is minus mgh. So the total work done on the system is 0. Now, if you are lifting a briefcase or some object from the ground level upwards, the distance h, say h is equal to 10 meters. You are lifting that briefcase 10 meters upwards, and if you are keeping the briefcase again 10 meters downwards, you will experience some difficulty in your body. So you need some effort, and you will, after say 1 or 2 trials, or about 5 or say 10 or 12 trials, you will feel exhausted. But actually, the work done on the system is 0. So the work done on the system is 0, but you will feel tired or you will feel exhausted after some time. But the work done on the system is 0. So this is a special instance in which the work done is 0, although we think we have some visual perception that the object has some work done that is not 0, but the actual work done is 0. So this is a special instance in the work done by a force F. So the second instance is when an object is in rotational motion. Rotational motion, actually I will not explain what is meant by rotational motion and the concepts in rotational motion. So if you are not well versed with the subject of rotational motion, I invite you to watch my videos on rotational motion and come back here, because it will be very easy for you to understand the concepts, because all my videos are in a sequential order. So in a sequence, because if you are not well versed in rotation, it will be hard to understand what is going on here. So if you have some understanding about rotational motion, it's okay. But if you are new to this concept, and if you are new to rotational motion, I invite you to watch those videos and come back here and watch this and continue. So I'll continue taking rotational motion of an object. So this is the center, O, and in rotational motion, what happens? This object, I'm taking circular motion. The circular motion and rotational motion are almost similar. The only thing is that circular motion is just different from the rotational motion, in the case that the circular motion is around a fixed point, traveling around a fixed point, and rotational motion is the motion of an object, the angular motion of an object around a fixed axis. So if you take the Earth and the Sun system as an example, the Earth goes around the Sun while rotating around its axis. So the total system, the total motion of this object can be considered the angular motion. The rotational motion of the Earth is the motion that it rotates around its axis. The circular motion around of the Earth is the motion that it goes around the Sun. So the motion of the Earth is a combination of rotational and circular motions. So I am considering circular motion, which is similar to the Earth rotating around the Sun, if you are not well versed in the subject of circular motion. So this is, if you have now to go in circular motion, you need some force F. So I will take a string as if it is fixed here and rotating about this fixed point. String, I'll put some force F here so that there will be a change in the velocity, and this goes in circular motion like this. Circular motion. So this distance is r, and by circular motion the force is perpendicular to r. So actually the force is tangential to the circle. So this is perpendicular. Alright. So if it's perpendicular to r, so the work done by this force is W equals F times cos theta times r. So F times cos theta is cos 90 times r. So you know that cos 90 is 0, so the total work done is 0. Now this is also similar to this concept, in which that when you have some string, and say this is the string you are taking, this is the string, this pencil is the string, you rotate this pencil around a fixed point, and you are rotating and rotating and rotating. You keep on rotating for a few cycles. You feel exhausted, you feel some effort, you feel tired when you are doing that, but the actual work done on the system is 0. So this is also very much similar to the instance that I was discussing in the early part of this video. So again, if the force is perpendicular to the radius, also we know that the W is equal to 0. So in rotational motion also, the work done on the system or on the rope or on anything that is included in that system is 0. So in this video I have been talking about two examples in which the work done on a system is acting on special occasions. So the work done on both these instances was 0, although we see that actually if you are experienced in this, you will see that there is some work done, but in a mathematical way or in a calculative way, work done actually is 0. So these are two examples in which the work is 0 and two special occasions. So that's the end of the videos on work done. So I will explain the concept of more concepts in mechanics in the next few videos, and thanks for watching this video, and see you then.